Good morning to everybody. I am Ramaswami, faculty from Department of Naval Architecture and Offshore Engineering. Today we are going to discuss about an important topic about the ship stability. Ship stability is a very interesting and discovering nature in the subject. We all must be knowing or may not be knowing or still may be thinking that how a ship is floating in a water. It is an amazing one, very interesting one. What is stability? It is the ability of the ship to come back to its original position once it is disturbed or inclined or deviated from its upright condition. See, we all know that ship means it is floating in the water. The ship never floats in the water as a steady state. Never. It happens once in a blue moon like that. Always there are forces which tries to disturb the ship when it is moving. A ship moving in the sea should be always upright. That's what we expect. But it is not like that. When a ship is moving in the sea, it is disturbed by various internal forces and external forces. So today we will discuss about what are the external forces and internal forces and what is stability. Stability, when you say stability, ship has got basically two types of stability. One is transverse stability, another one is longitudinal stability. As a beginning, first we will discuss about the transverse stability, which is an important and most relevant to the topic. Stability, when you say the ship must float upright and move. What are the conditions for the ship to float upright? That is very, very interesting one. See, we know that ship is floating in the water. When ship is floating in the water, there are forces acting on the ship structure as well as forces from the water. That means on which the ship is floating is also acting upon the ship's structure. Now, what are these forces? These forces, we can say, one is gravitational force. That is the force which is acting downward due to the weight of the ship. We know that for every action there is an equal and opposite reaction. That is Newton's third law. So here also, when the force G acting downwards, that is, we call it as the gravitational force, center of gravity of the ship, through which we assume that whole mass of the ship is acting downward. For this center of gravity force which is acting downward, there must be a force which should be acting upward also. That is the force which is created from the water, down from the water. That is due to the water which is acting and on which the ship is floating. That force is nothing but the buoyancy force, which acts due to the weight of the ship acting on the water. So the water also exerts an upward force on the ship structure, that is called the buoyancy force. So this center of gravity and center of buoyancy acts equally and opposite. So that makes the ship to float and move. Now the question is that where the center of gravity will act, where the buoyancy force will act. That is a very interesting one. The center of gravity acts in the centroid of the ship structure. The center of gravity depends upon the center of gravity of the ship or mass of the ship. When the center of gravity will change or alter or move, the center of gravity will move once the center of mass of the ship changes. That is, addition of the mass, shifting of the mass and removal of the mass. on this criteria, on these conditions, the center of gravity of the ship will move. Whereas the buoyancy force is a force which depends upon the underwater volume of the ship. What is underwater volume? Underwater volume is nothing but the volume of the ship below the waterline. Waterline is what? Up to which level the ship structure is immersed inside the water. We call it as a draft, ship's draft. Normally, the ship's center of buoyancy depends upon the drafts of the ship, draft. Normally, for a rectangular cross-sectional vessel, the center of buoyancy will be lying off of the ship's draft. Okay. So, both these forces, center of gravity as well as center of buoyancy, will act in the same line. Center of gravity acts downward and the center of buoyancy acts upward. These two forces which balances the ship and makes the ship to float upright. Then we can move the ship, we can add the cargo, and we can see the ship is in equilibrium state. When the problem will come? The problem will come when there is a change in underwater volume. When there is a change in underwater volume, we cannot expect that the ship's underwater volume will remain constant. It keep on change due to the heeling of the ship. What is heel? What is heel? Heel is nothing but the transverse inclination of the ship. This happens due to the external force. This happens due to the external force, that is wind, wave, underwater current, which the ship will normally experience when it is moving in the sea. So when the ship heels, the underwater volume changes. Once the underwater volume changes, obviously the center of buoyancy will shift. Obviously the center of buoyancy will shift. It will shift towards the volume, underwater volume moves. Wherever the underwater volume is more, there the center of buoyancy will shift. Now what happens when this center of buoyancy shifts? When the center of buoyancy shifts, there is a lever created between or a distance created between the original center of gravity and the new center of buoyancy. Earlier we saw that both center of gravity and center of buoyancy are acting in the same line. Now the center of buoyancy shifts due to the ship heeling, that is due to the external factors. Since it is due to the external factors, center of gravity will remain unchanged. It will not move. Center of gravity will only change when there is a change in internal distribution of ship. Internal distribution of change in mass of the ship. So here the center of buoyancy only will shift. Therefore, there is a distance created between the center of gravity and the new center of buoyancy acting upward. This distance creates a lever. We call this distance as a lever. Now a lever is created. This lever, what does it do? It will create a movement. It will create a movement. See, we have seen that due to external force, the ship has heeled. That means underwater volume is changed and the ship's center of gravity has moved from its original position to a new position. Due to this, what happened? The ship is inclined. When the external force is relieved, the ship must come back to upright state. How it is possible? It is possible due to the lever which is created. This is possible due to the lever which is created. What does this lever in turn do? This lever will create a movement. How does the lever create a movement? You know, movement is nothing but force into distance. Force is force into distance. Now, the force is nothing but mass of the ship and distance is nothing but the distance created between center of gravity, original center of gravity and the new center of buoyancy. Once this lever is created, the gravitational force acting downward, it will create a movement in a direction opposite to the angle of heel. It will create a movement in a direction opposite to the angle of heel. Once this external force is relieved, the waves or wind will not constantly act on the ship structure, but after a period of time it will go off. Once it is go off, the lever and the force of the ship, that is the ship's mass, ship's gravitational force acting downward, will create a movement in a direction opposite to the heeling of the ship. Thereby it will bring the ship to the upright condition. That is how the ship becomes upright when the external force is relieved after the wind waves goes off. This phenomena repeatedly acts so that the ship will be keep on rolling in the sea. This tendency we call it as rolling. It is a temporary phenomena where we can say that the stability of the ship is positive. Then the stability of the ship is positive. So this is the concept on which the transverse stability of the ship work. That's what we have seen. Regarding the longitudinal stability, we will discuss in the next class. Thank you very much.